Hello friends, welcome to the Unit 2 Day 3. In this particular video we're going to be going over the linear graph and rates of change. This one specifically focuses heavily on slope. The concept of slope is important in mathematics because it gives us a way to measure and compare essentially change. And that's like at a very fundamental basis. You know, it's just talking about change. Usually it talks about rates of change or, something along those lines. But really we want to know slope. Slope allows us to compare rates of change. And then I gave you an example here. The circumference of a circle increases as the radius increases, and the value of an automobile changes with time. That is combining two examples. So we're going to just ignore this last part, because what it's essentially saying, there should be kind of another kind of break in the sentence. The value of an automobile changes in time is it's essentially its own sentence. It's not connected with the circumference of a circle. As you have kind of the worth of an automobile, usually it decreases over time. Sometimes it can increase over time. Sometimes it decreases and then it increases. All these types of things we're going to be talking about as we move through this particular section and course. So these are examples of slope or rate of change. The slope-intercept form, this is a review, is y equals mx plus b. M is our slope, and b is our y-intercept. You will see me frequently use b colon, 0, comma, and then whatever the value is for the point. I do that specifically to point out that b is a point. A lot of students think that b is a number. It represents a number. In terms of this equation, its location within this formula, it is generally a number, sometimes an integer, sometimes a rational number. But when we write it out, when we talk about it in terms of graphically, it's represented by a point. It's not represented graphically as a number, but a ordered pair or a coordinate. So for this first one, it says, solve the equation for y and evaluate when x equals -3, x equals 5, and x equals 6. So I'm essentially kind of developing a table here. So first, let's go ahead and solve it for y. So example 1, let's go ahead and get, again, the 3y by itself. So we're going to add 2x on both sides. Add 2x, add 2x. We get 3y equals 2x plus 9. Divide by 3 on both sides. A lot of students will just make a single bar all the way across. Please don't do that. That is not mathematically accurate. When you're using the division property of equality, you're dividing on this side and then everything on this side. Notice that I created an entire rational bar, fraction bar, under both of the terms. I'm dividing both of those by 3. These 3's cancel to become 1, so I have 1y or just y, equals, and then I'm going to go ahead and rewrite this as 2/3 x plus 9/3. I'm going to go ahead and reduce 9/3. 9/3 is 3. And that gives me my value. Now for this, what I can do is, in this next part, it talks about evaluate when x equals -3, x equals 5, and x equals 6. And what I'm essentially asking you to do is evaluate what these values are, what the y value is, when x is this value. Going back to our previous section, we're talking about input and output. X in this case is the input or the domain values. Y is the output or the range values. When I plug in -3 in for x, I'm going to have y equals 2/3 times -3 plus 3. There's some canceling that I can do here because I have a 3 in the numerator and the denominator. So by canceling, I just have a negative. That's -2 plus 3. So y is going to equal +1. If I plug in 5 in, then I'm going to have y equals 2/3 times 5 plus 3. This doesn't cancel. I get 10/3. Y equals 10/3 plus 3. To add fractions with unlike denominators, I need to have the same denominator first, so this is going to become 9/3. That way I can add them, multiplying the numerator and the denominator by 3. So this is going to be y equals 19/3. And then for number 6, plugging in 6 for x, this cancels to just be a 2, 4, 4 plus 3 is 7, so y equals 7. A lot of students want to convert this to a decimal if it was allowed to on a like on a test or an exam. Notice that because it's it's 3 in the denominator, you're going to have a repetand, a repeating bar. 19 divided by 3 is going to be 6.3 repeating. I'm using the equal sign here to show that these are mathematically equivalent. If I did not have that repetand, that bar that's above the 3, that doesn't show that it's repeating. So you can't just put 6.3. That means 6 3/10. That's a very different number entirely. So because I'm putting that repetand, it shows that it does continue on. Very quick, I will leave x-intercept and y-intercept for the next video as we go over example 2. Have a wonderful day. See you soon.